I'm going to talk about more the practical side of how to measure specific power, what tools to use for that, and I will give you also examples of how you can implement this in a real system. You know, it's similar if you drive a car in the city, instead of on a highway, you might have a very fuel efficient car that is efficient on the highway, but it might be less efficient in the city, like electric cars versus gasoline cars, for example. So, and also you have to take care of your tires, to keep them on the right pressure, to have the friction as low as possible. And we see the same for compressors. So you can have a very nice compressor based on the spec sheet, but in practice, the specific power might be a little off of that. So I think Tom already explained a lot about what a specific power is. So I will skip that slide and talk about why specific power is important. Well, what you can do with it is basically track the impact of your downstream improvements, optimize supply side based on actual demand. And we have seen nice examples also of maintenance management of compressors. Like if you have centrifugal machines, specific power can be influenced by the inlet filters. If they get clogged, then you will see that the output flow can go down. And also, just as Tom mentioned already, flow-based smart control systems. In those cases, you can also use specific power to select the right compressor for the specific demand. Another thing we are doing also with monitoring is benchmarking of various compressor rooms. If you have similar plants with similar production setups, you can use this as a benchmark KPI to look at plant A versus plant B and which one is running more efficiently. So this is a basic setup of a simple way to do efficiency monitoring in a plant. So in this case, we use single phase power meters, so it's actually amp meters, and one flow meter at the end after the receiver. And this can provide already a good number and good results on the total system efficiency. Of course, you could expand this with also amp meters on the dryers and also measure the power consumption of the cooling to make it more complete. But this is a good starting point. If you want to start quick, then this is a way to do it. Those Rogowski style meters, you can also install them very quickly, but I will come back to that later. And a more advanced way of doing it is you could do individual efficiency monitoring on each compressor, and then also use three-phase power meters that measure also the voltage, and you can have cosinus phi and all those extra parameters out of those meters, so it's more accurate. And you can look at individual performance curves. So, and this is the curve you already saw in the previous slide, and also here in the right corner shows what happens if you have an oversized compressor running always in the very low end. You see all these colors are different weeks of production, and you see that this machine is sometimes running quite often in the low range where the specific power is not so great. Tom also addressed that point, and it's important to average things over time. If you look at an instantaneous number, we can do that in permanent monitoring. You can have an instantaneous real-time specific power number, but in that case you will see that it flips all the way up and down when a compressor goes in load or unload, and the flow is changing in a different way. Then you will see that that number goes basically all the way around, and that's not really useful. So it's always important to average flow and power consumption over a longer period of time. For example, at least an hour. And I like, by the way, what Tom presented on using the case index. That's another way to get rid of those fluctuations in an elegant way. And if you have that number, then you can start to use it to manage your assets. So to see the effect of clogged inlet filters, or sometimes you can reveal also issues with cooling of the compressor. And if you have an oil-free compressor with a Teflon coating on the rotors, in some brands, you might even reveal some wear of that the efficiency will change a little bit over time. Compressor sizing, so it's a great way to find out if your compressor or the combination of compressor is undersized or oversized. That might be, it was a good compressor in the beginning, but maybe the demand has changed over time. So that is also something which can, of course, influence the efficiency. And then the control system optimization. So we have now these fancy controllers that can automatically select the right compressor combination, and we sometimes do partner up with these control systems companies that make these controllers. So if you're interested, I can always refer you to them. And there are also environmental factors, so especially with centrifugal machines. So when you're monitoring specific power on those machines, I recommend that you also add an environmental sensor that can measure ambient pressure, ambient temperature of the compressor room, and maybe also inlet air temperature if there's a duct, and also cooling water temperature, because those are all of influence on the efficiency. So it's good practice to monitor that as well. You know, it can be on a 15-minute or an hourly basis, because this is not normally changing much. But this data is very useful when you want to come to the right conclusion. This is an example of a factory in Turkey where they also used a specific power as a KPI, but in this case, it was used to prioritize the replacement of old compressors. So basically, they were looking at each compressor, what is the output flow, what is the input power, and when some compressor was really off the charts, then they would first replace that one. So in that way, monitoring the efficiency was basically helping them to make the right decision and to also manage their cash flow a little bit. You know, not replacing all the compressors at the same time, but just do it step by step. Now, what can you use to measure the power? Because that's, of course, the first parameter you want to measure, the input of the compressor. There are basically two types of ways to do that. You can use a single-phase Rogowski coil sensor, which is like a bracelet, very easy to install. Or you can take a three-phase power meter with current transformers and also real-time power measurement. And they both have their advantages and disadvantages. These Rogowski style meters are very quick to install. It's like you just really like putting on a bracelet. So you can install them on live bus bars, even in tight spaces you can put them in, and they have quite a large measurement range. So it's like a one-size-fits-all solution, and you can also install them quite safely on hotlines if you know what you're doing, of course. The only thing, they lack the voltage measurement. So you need to do a one-time voltage measurement to check the voltage, so you know what the power will be in the end. So you can use that voltage in your power calculations, and you might want to check that regularly if you doubt that it will be stable enough. So that's the downside. So typical applications are, well, they are very good, of course, to monitor a compressor on, off, standby. They're basically overrated already for that because they are quite accurate. You can use them to do a estimated power consumption calculation, use the monitoring software behind it, and it's really a quick check during audits. Not only for compressors, you can also use them on pumps, on lighting, all kind of stuff. Then the three-phase power meter, more accurate, but the downside is that the CT has a fixed form factor, so it's sometimes harder to install, and the CTs need to be properly sized to basically fit on those power cables. In some cases, it requires powering down the system to install these things safely. Of course, the advantage is the continuous voltage measurement, so you have a more accurate power measurement. So what you will see is that they are sometimes required if you do like you are participating in a tax incentive or a rebate program. They're typically used also for sub-metering. Yeah, but basically because they're more accurate, and in many cases also they come with a certificate that they are approved for billing, for example. Now, flow measurement, that's another story. It's also something you need, of course, to calculate the specific power. And you want to install them basically, for example, in the outlet of the compressor, if you want to do an individual compressor efficiency monitoring. But in that case, it needs to match the harsh outlet conditions. There's water, there could be high temperatures, temperature swings, and there might be oil in the line also. So this is not the easiest environment to put in a flow meter. So some technologies are better than others. I recommend to use 3-in-1 flow meters. So you have mass flow, you have pressure and temperature in one. In that way, you really have the complete picture. So you can see the relation between temperature rising, for example, that might indicate that the cooling is not perfect, or an intercooler is a little bit clogged, and the relation with flow and pressure is also very useful to have. It's best to use calibrated flow sensors. Sometimes people use these cheaper flow switches that are uncalibrated. Nice maybe as an indicator, but if you want to see the real numbers, I recommend to use calibrated flow meters with a certificate. But these have also some downsides. If you use it like insertable probes, you need to be also taking care of the insulation conditions. So for example, if the pipe is very short after a compressor, you might run into insulation errors, which can really affect then the number that you're reading. And it's not always a problem because it can still be a very good way to trend the efficiency, but you need to be clear with your customer to say, well, this is not the best super accurate meter. It can be used for trending, but don't blame it on the compressor manufacturer if the number is a little bit off what the spec sheet specifies. Last but not least, compare apples with apples. So some flow meters have a reference condition of 20 degrees, some of 0 degrees, and it also counts for compressors. So make sure that you're looking at all compressors in the same way. Even if you have a mix of like centrifugals and rotary screws, I recommend to choose one of those standards, like either 20 or 0 or 15, but don't mix it all up because it makes it very difficult to do your assessment. Flow meters also provide other information that can be of use, like you can make histograms of the air demand, which tells you whether you are in the sweet spot or whether you are a little bit off. So it helps you to select the right compressor. You can also find system leakages. When those compressors are off, you can find, for example, reverse flow when a non-return valve is actually not really working properly anymore. This is an example of two flow meters that are not installed properly. So two good brands. You see here a Bico and then a VPInstruments flow meter, but both misapplied. So yeah, be sure that you install them properly. So in this case, you see a thermal flow meter in the discharge pipe where it can be wet. So that's not a good plan to do. And here you see a differential pressure flow meter in a T-piece which is of equal size, so you get a lot of turbulence around it. That can also affect the measurement. If you want to know more about this, we have a separate presentation on how to install and how to select the right technology. So feel free to contact me after this webinar about that specific presentation. Also, undersizing sometimes happens. When you use an undersized flow meter, then of course the flow will clip at some point. It cannot go higher. And in that case, yeah, of course, your number is not correct anymore. And coming to the end of this part, you can also combine everything in one monitoring system. So you have flow, power, dew point, demand side flow, and that really helps you to make the right decisions on what to do next. Maybe it's not changing the compressor, maybe it is just buying a bigger receiver tank to overcome that peak demand, or maybe you need to invest in a better dryer. So yeah, to monitor it all will really help you to make the right decisions. And then you can make these nice reports, fully automated nowadays, where you can have an overview of all the critical performance indicators and then use that as management data to make your daily or monthly decisions. So coming to an end of this part, when monitoring compressor efficiency, you should yeah, look at what do you want to reach with this. Is it just trending to do maintenance management, or is it something for legal compliance, or for example for a very large air over the fence contract? And that might really influence what type of sensors you want to use, or even sometimes you want to have redundant sensors because there's a lot of money at stake. And be aware of those uncertainties, like the single phase amp meter versus the three phase power meter. If you know what you're using, you can clearly communicate to all the stakeholders, you know, the pros and cons of the chosen technology. Take the latency into account, or use the case number I just learned, so that your real-time measurements are stable enough. So basically, you don't want to have a real-time number that's flipping all around. So then average it over time. And last but not least, choose the reference conditions and stick to them. So you can always compare to the apples to apples and avoid a lot of confusion. So this brings me to the end of this part. If you have any more questions, you can ask them after the, of course, in the Q&A, and or send me just a mail after the webinar. Thank you.